Today we're going to talk about slope fields, and slope fields are a graphical representation of a differential equation. So we'll draw some slope fields, and then we'll start seeing what they do for us. So to draw a slope field, we need to find some slopes. So I'm just going to create a table here, and there's different ways to organize this, but I'm going to have x, y, and then dy dx, which in this case is negative x over y. Okay. Doing some obvious ones. When x is 0, any of my y values, I'm going to have 0 over something. So all of my slopes when x is 0, my slopes are going to be 0. So on the slope field, what you're going to do is just a little dash that has a 0 slope. Okay, on the other case, if y is 0, no matter what the x value is, the slope is going to be undefined, which means those slopes are going to be vertical lines. Okay, but the rest of them are going to be values. Okay, so if I plug in the 1, 1, so we have 1, 2, 3, 4, 16 more points to calculate. If I plug in 1, we're going to have negative 1 over 1, which is negative 1. So at the point 1, 1, we're going to draw a line segment that has a slope of negative 1. Now I'll use as a guide, if it has a slope of negative 1, we'd go down 1 over 1. So just that slope there. If I wanted the point 2, 1, my x value is 2 over negative 1 gives me a negative 2. So this one, I'm going to kind of aim halfway between there because the next point would be up there. Okay, I'll do the first quadrant and then we'll talk about what that does. So 1, 2 is going to be negative 1 over 2, which is a negative 1/2. So I'm going to draw that one slope with a slope of 1/2. So it kind of aim towards the middle here. Last one is going to be 2, 2. Which is going to be negative 2 over 2, which is negative 1 again. Okay, so that's the first quadrant. Thinking about what that's going to change, the values for the corresponding points are going to be the same. So like 1, 1 is going to be the same as negative 1, negative 1, except for it's going to be opposite. So here my slope is going to be positive 1. This one's going to be, and you can go through and calculate all these if you want to. That one will be the same as this one, but positive. This one will be a positive 1/2, and this one will be a positive 1. Same thing here because our x's will be opposite, but the y's will be the same. So this will be 1, this will be 2, this will be 1/2, this will be 1. In the third quadrant here, the values will be negative over negative, so they're going to be the same as what we have here. So this one is a negative 1, this one's a negative 1, this one's a negative 2, and this one's a negative 1/2. Now on an AP exam, and we're going to do some AP questions later, you won't have to do this many, but for right now we're just getting some practice. Okay, so our next one, we have x, y, and the differential equation is just x. So the slopes here, when x is 0, no matter what the y value is, our slope is 0. When x is 1, no matter what our x value or y value is, the slope is 1. And so on. So negative 1 is going to be negative 1. So when x is 0, our slopes are 0. When x is 1, our slope is 1. When x is 2, our slope is 2. Okay, and then negative 1, no matter what the y value is. And then negative 2, no matter what the no matter what the y value is. Okay, so x plus y. You might pause it and try to do this one on your own because the math is pretty simple. Plus y. So let's start with 0, 1. So 0, 1 is 1. So we have a slope of 1 here. If I have 0, 2, I get 2. So this one's got a slope of negative 2. Go ahead and do 0, negative 1 is negative 1. 0, negative 2 is negative 2. Okay, and then I'll just kind of add some of these in my head. So we're adding the coordinates here. So this is 1 plus 0, so that would be 1. This would be 0 plus 2, so that would be 2. This is going to be 1 plus 1, which is 2. This is going to be 1 plus 2, which is 3, so we'll try to make that steeper. 2 plus 1 is also 3. And then 2 plus 2 is 4. I'll try to write that steeply. Okay, 0 plus a negative 1 is negative 1. 0 plus negative 2 is negative 2. Okay, what about this? Negative 1 plus 1. Well, that's going to be 0. Okay, negative 1 plus 2 is a positive 1. Negative 2 plus 1 is a negative 1. And then a negative 2 plus a 2 is again 0. 1 plus negative 1, 0. Go ahead and do 2 plus negative 2, 0. So this whole diagonal here is 0 when x and y are the same but opposite. Here I have 2 plus negative 1, so that's going to be positive 1. Here I have 1 plus negative 2, which is negative 1. Okay, negative 1 plus negative 1 is negative 2. Here we're going to have negative 3. Here we have negative 3. And then negative 2 plus negative 2 is negative 4. Okay, now I have 6 different slope fields, and I have 6 different equations. And what we're trying to do is match which equation goes with which graph. So you can do this a couple different ways. You can look at the slopes and what those are going to look like, or you could integrate this and figure out what this would look, what that actually equation is, and then try to match the graph this way. I look at something like x squared. If I think about the slopes, no matter what I plug in here, number one, y doesn't matter, okay? No matter what the slope is at x, the slope at the different y values isn't going to change. So as you move up and down the y-axis, your slopes aren't going to change, but it will depend on x. The second thing I look at, well, if this is x squared, the slopes are always going to be positive no matter what I plug in there. So if we look at that, here I've got some negative slopes. This one is all positive slopes, plus, so when x is 0, our slopes are 0, and as they increase, the slopes increase. Same with the negative. Okay, so this one is y equals x squared. Okay, similarly with this one, the y value is going to dictate what's happening. The x value is going to change. The different x values will have the same as the y. What I mean is, whatever the slope is, x's isn't going to change it. Another thing I look at here is, okay, well, when y is 0, my slope is going to be 0, always. Or when y is 1, our slope is going to always be 0. So looking at these different graphs, here, when y is 1, my slope is always 0. And then thinking about this numerically, if I plugged in a number less than 1, then my slopes are going to be positive. And if I plug in a number bigger than 1, my slopes are going to be more and more negative. And then the x values don't change that fact. So that's going to be that guy. Okay, cosine. Okay, we know what the graph of cosine looks like, and what we're doing, thinking about the integral, it would be sine. We're also looking at something to be cyclic, and again, it doesn't depend on y, so the different y values are all going to have the same slopes. So this one is hopefully pretty clearly you see this one is going to keep going up and back down, and it doesn't depend on the y's. X plus y, we actually just did this one, but characteristics we're looking for. So now we're down to these three. Since we just graphed this, we know when x plus y are the same but opposite, we're going to have a 0 slope. There's two variables in the mix here. So that's going to be this graph right here. Okay, y times 2 minus y. So this one, when y is 0, my slopes are going to be 0. And when y is 2, my slopes are going to be 0. So that's going to be this equation right here. And again, it doesn't depend on the x values, so they all look the same. Last one leaves us with 2x. Okay, which we only have one left, but if we think about it, when x is positive, my slopes are going to be positive. When x is negative, my slopes are going to be negative. So this matches. Also, if we think about this, the integral of this is x squared, and if you look at these lines, they kind of look like parabolas, and we'll get to that in a minute here. All right, so this next one, we have just one graph, but a bunch of different equations. So looking at these slopes, in the first quadrant, all of these slopes are different, but they're all positive. In the second quadrant here, these are all negative. In this quadrant, they're all negative, and in this quadrant, they're all positive. So the x value is dictating whether it's positive or negative. The y value is not. Okay, so here, this would change in the different quadrants, because if I had a negative over a negative, we'd end up with a positive there. Here, if I had a negative over a negative, when I'd squared it, we'd again get a positive. Here, and I'll use this quadrant again, if I had a negative x over a negative y, this would be negative, this would be positive. Well, if this was negative, it's going to be negative over positive, so that one works. And then positive, 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 positive. So this one works. Let's look at this one. I'll again jump to third quadrant. If I plug in a negative over a negative, we're going to get a positive. So looking at the signs of the slopes, I can choose that as my answer. All right, so we have a differential equation for 0.36x over y. We're going to start at the point 0.06, which is 1, 2, 3, 4, 5, 6. And we're going to draw the particular solution. So we know when we do when we're solving a differential equation, we always have that plus c. So based on the plus c, the particular solution can be an infinite number of things. So here we're going to look at the particular solution starting here. So essentially what you're going to do is kind of connect the dots. You're going to match the slope at the particular point. So here we're horizontal, but as I move out, they're kind of starting to get slightly curved. Just kind of going in between the dots or parallel to the dots. And we end up going straight down there. Starting to level off to here. Oop, I missed it. I should have gone in there. Sorry. Okay, matching the slopes. Okay, and then up again, matching those slopes, which is going to bring us back to what we started. Okay, so what shape does this appear to be? Well, if you remember back in Algebra 2, this looks like an ellipse. Okay, we're going to do the same thing starting at 5, 2. So each of these dashes are 1. So 5, 2 is going to start here. So the slope is starting here, it's going to go vertical around there. Okay. So we get another ellipse, just a smaller ellipse. Okay, so let's look how this relates algebraically. We're going to solve the differential equation, and we're going to use the 0, 6 as our initial condition, and then we're going to match that to our graph here. So if I separate my variables, we're going to have dy over y equals negative 0.36x dx. We'll integrate that. Sorry. We're just cross multiplying here. So this is just going to be y dy equals negative 0.36x dx. Been too many logarithm problems. So this is going to be 1/2 y squared equals negative 0.36 times 1/2 x squared plus c. So I can multiply by 2 to get rid of that 1/2. So y squared is equal to negative 0.36x squared plus c. So I'll go ahead and do the initial condition at this point. So 6 squared is going to equal 0 plus c. So my c is 36. Okay, well, if we remember ellipses, the x squared and the y squared are on the same side. So I'm going to do negative 0.36x squared, not negative, equals 36. So then I want this to be a 1, so I'm going to divide everything by 36. So 0.36 divided by 36 is going to be 1/100th. So this is going to be x squared over 100 plus y squared over 36 equals 1. So this is the equation of an ellipse where the major axis is along the x-axis with 10 and negative 10. And then if that's 36, then that's where the 6 and negative 6 are coming from. Okay, so we're going to sketch a few particular solutions. So you can pick wherever you want, just to get kind of used to this. So I'm going to draw a couple. Pause it and draw them. Okay, so sketch a few solutions to this. So I drew just following the lines, and this is what we came up with. So what does it look like? Look like circles. So let's see how this relates to that. So I'm going to cross multiply. So we're going to have y dy equals negative x dx. So 1/2 y squared equals negative 1/2 x squared plus c. We can multiply out that 1/2. Okay, and then I'll add that over. So we'll have x squared plus y squared equals c. So that gives us a circle. All right, so here's an actual AP problem. We've got the differential equation kind of similar to the last one, negative 2x over y. So we're going to go ahead and find the slope at the 12 points. But 4 of them are easy. When x is 0, the slope is going to be 0. Okay, so then I just need to plug in the different points here. So I'm going to do this in each quadrant. So we've got 1, 2, and 1, 1. When I plug in 1, 2, I'm going to get 2 over 2, so that's going to give me negative 1. And then if I plug in 1 over 1, then we're going to get negative 2. Okay, these slopes, and we're just plugging it into the differential equation, is going to be 2 and 1. Okay, so similarly, this is going to be a positive 1, sorry, positive 2 and positive 1. And then here, negative 1, negative 1, negative 1, and negative 1, negative 2. When I plug those in, we're going to have a negative over a negative, but we're making that negative, so they're both going to be negative. This one will be a negative 2, this one will be a negative 1. All right, so there's the slope field. Okay. It says let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. An equation for the line tangent to the graph of, so we're going to find the tangent line and then use it to approximate. Well, for a tangent line, we need a point and a slope. Well, we already have the point, 1, negative 1. So we want the slope at that point, which we've already calculated up here, is 2. So my tangent line is going to be y plus 1 equals 2x minus 1. So y is going to be 2x, this would be minus 2, minus 1 is minus 3. And you can just leave it like this, but since I'm going to be approximating, I didn't. So we would just leave it like this on the AP exam, because this would be 2.2 minus 3 is negative 0.8. But again, just leave it like that. The last part of this problem is asking for the particular solution. So we're going to separate our variables. So we're going to have y dy equals negative 2x dx. So again, we have 1/2 y squared equals negative x squared plus c. So y squared equals negative 2x squared plus c. This one I am going to take the square root, because if it's y equals f of x, that means we have a function. So this is going to be plus or minus the square root of negative 2x squared plus c. Okay, our initial condition here is going to dictate whether it's the positive or the negative, which in this case is going to be the negative, because if I plug in a positive, we want our answer to be negative. So I'm going to do my initial condition. To find c. So I'm going to square both sides, so I get 1 equals negative 2 plus c. So 1 plus 2 is 3. So my final answer here is going to be f of x is equal to negative square root negative 2x squared plus 3. So when you're given an initial condition like this, you'll need to decide whether it's the top half or the bottom half. So that is our introduction to slope fields.